All right, continuing with our introduction to truth tables, we've talked about the AND statement, we've talked about an OR statement, where one or the other would have to be true, etc. Now let's talk about a third type called the conditional statement. Okay, so the conditional means if A is true, then B must be true. And we draw it like this arrow. Sometimes we call it A implies B. But we can also say if A, then B. If A is true, B sure as heck better be true. Okay? So here A is true, so B needs to be true. So that one's fine. That one's true. Okay? Here A is true, B lets us down and is not true, so that would be false. Okay? Now here's the interesting part. If A starts out false, we don't care. B doesn't have to be anything. We're just guaranteed that it's true. Okay? Let me use our regular notation here. So we say if A, then B. It's called the conditional statement, and the condition is true except for when true points to false. If A was true, B lets us down by being false, we'll say. If A is true, B needs to be true. If it's false, that's when our condition fails. Anything else is going to end up being true, okay? So let's step through it again. Again, if A is true, B needs to be true, and it is, so we're good, and we got the true here. If A is true, but B is false, that's our problem. Okay, that's the one we mentioned here. That's a problem, and that's the one time we end up with a false here. If A is false, we're not promised anything, so B doesn't matter. We're still okay. We still can be true. Okay, A implies B again means if A is true, B needs to be true. And if it's not, that's the one thing that leads to a problem of being false there. Okay, erase these for a second. And so here's finalized, just recapping again. I'm going to get this one down, make sure you understand it. But if A is true, B must be true. If not, B can be anything. Okay, so get used to hearing that. That's how this one works.